Today we're gonna do learning tutorials. Haskell. I had my eye on one for a while, the parser combinator one. I haven't done it one before, so it may be interesting. It may not be. We'll see. But this is gonna be entirely focused on beginner Haskell. So actually, one thing I want to do is in the hack screen, I want to add a little thing that says ask questions, man. Right. Ask questions. Whenever. Ask. Questions. Please. And please. Okay, that's nice. Want to have a little blackness around it so it's more obvious. Maybe background too. What is this? What's this? Yeah, I'm just setting up, guys. So we're gonna do the parser combinator course. I have it linked in here. And I also made a Git repository for sharing this stuff in. So I'm just gonna merge in the course into that. And then, yeah, parser combinators. Let's do that. So we're just gonna merge in this entire thing into the other repository, and then we can just work on it. And I can like push upstream my answers. That's my idea at least. Because for this stuff I don't really care if it's public. The other project I'm working on, yeah, it's my own reg. But it's forked. How about that? Buddy Morris. I actually met this guy too. But he apparently put it in data 61. Good for him. So there's a lot of stuff in here actually. Oops. What is this? Ansible, Haskell. What's going on, man? That's weird. I'm not so happy with the screen thing either. I'm just gonna put it over to chat again, because I often have to look there. Go here. Yeah. Like that. Yeah, that's good. Git remote add. Not origin. This is data 61. Parser combinator. Let's see. I can probably just merge that in now. Git one master. Using to merge unrelated history. Oh, unrelated. I just can't spell. Been plaguing me since forever, man. Gonna make it there, data 61. And move all this shit into there. This works for some reason. I want to move the checklist out again. Which checklist? Running server not responding. What about that? Still have this stuff running too. Yeah, go run again, man. Wanna have chat. Oh, that's the wrong colors for some reason. Are you alive now? Okay, let's see. They have a Nix shell, so we can just use that to basically get the build tools we want. If you're unfamiliar with Nix, it's basically independent package manager kind of thing that works on any operating system, as long as it's Linux. Well, any distribution then, at least. It also kind of works on OS X, but with some... There's a Nix shell, right? There's a default.nix. What is that? So I'm using the Nix stuff because it allows me to avoid having to deal with basically Cabal, which is kind of hard to get into. They like prepare it for me and stuff like that. Haskell tooling is not that user friendly. It's really good, but it's not. It's like you have to learn a language and then you also have like to use tooling. And the best way to get into this stuff is maybe actually Stack. But because of choices I've made, like using Nixos, I can't use Stack right now. That's fine. But if you wanna like also do this course, the Data 61 parser combinator course, then you probably should use Stack. I'm not sure. Actually, where was it? Tic-tac-toe? What is this? I lost it again. There's... I have to link record it somewhere, but I think I found it through Google. Just the file from GitHub. So yeah, if you have any questions about what I'm doing, you should totally ask, because this is the learning club, and hope to get a... Right, so this is a FP course, Master Circ course parser. Okay, there's a lot of stuff in here. I'm just like I've never seen this before. Oh, there's a lot of stuff in here. But we're gonna do parser. It's like a classical thing to start with, I think. I'm not sure how much I should explain. Should I like also explain some types? Nope, we're just gonna do exercises. And we know something is an exercise because there will be an error. And let's see, there's comments too, so maybe you should read those too. Right, so they expect you to load this into GHCI, and then you can just like run your example code too. But it shouldn't be necessary, because once it compiles, it should just work. Except if you use this stuff, which will become any type. This is like cheating, right? But it also like will just, if you run this code, then it will blow up in your face. Yes, Haskell is a type-safe language, except you can, you know, get around it if you want. Right, so we entered the next shell now. Maybe we'll have a cable. Yeah, we have a cable. Okay, do we have GTI? Also GTI, that's nice. Let's import that file then. Import. Is this like one large project? Yeah, I think so. Cable.project. Let's see what's in there. Oh, it's just this. Okay. Course.cable. Right, so this is not really Haskell, but it's the build tool around Haskell. And you will kind of have to use that if you want to do any Haskell dev. But yeah, that's why I'm opening this. So we can import course.parser. Let's see what happens. Let's find module course.parser. Well, that sucks. Why can't you find... Did I misspell? Maybe it's like... that's not good. Do they have like a readme or something? How am I supposed to use this stuff? Thanks for the branding, man. What is this even? You should note, if you've arrived here by looking for answers, not the exercises. Yeah, we don't care about the answers. Like, we're gonna decide for ourselves if something's correct or not. I don't wanna look at their stuff. Maybe at the end, but I'm not really interested usually in that. I can decide for myself if something's working. Support is taking place in the repository hosted. Taken the place of the repository hosted at Nicta, of course. Data 61 replaces what Nicta is since. Right, so they renamed themselves. Yeah, Google Group, that's that. But we won't be needing any help, I hope. Because that would be annoying. But I doubt this is that advanced. Yeah, the problem is I got into GTI, but it couldn't find the file. Maybe I should go to Circ instead and open GTI there. Yeah, that seems like a good idea. How do I quit GTI? So yeah, Haskell tooling is fun. It's not. Wrong directory. You are in the wrong directory. Thanks, man. Maybe it needs to build first. Cabal build. Oh, that's probably the case. Like Cabal new build or something. Yeah, it needs to build first and then you can use GTI. And that's the reason for that is like it needs to have some of these files, I believe. Link against. I don't know. Now import. No, we don't know how to do this. Okay, that's a problem. Well, it would be really annoying to run then. Then I need to make my own main file. Yeah, that's a problem because I almost never use this stuff. I could not find module course.parser. But it's exposed, man. Isn't it? Yeah. Don't they have like notes about it? Getting started. Note if you do not want to install these dependencies, you may use a virtual machine instead. That's such horror. Okay. Yeah, you can always use a virtual machine, man. Instructions for automatically building a virtual machine are available in this repository for your convenience. Kind of interested in that one. Like, what will it tell? Like, download VirtualBox? Oh. Okay. Let's not get into that. Like, Vagrant is like Docker Compose except for virtual machines. So it's even more powerful, but it's also a lot of clunkiness, basically. Nick should have done this for us. Execute command GTI. We have GTI, which compile and load all the source codes. You may need to set the permissions on the root directory and GCI configuration file. Dmod go. Seems weird. I don't think I need to change any permissions. I should just have access to that. Go W. I don't have that user, I think. Yeah, that's probably for the vagrant stuff. Get a feel for Haskell syntax. Then move on the exercise and start with the course optional. Oh, they have like a list of stuff we should follow first. Now we gotta do parser. Combinators too. Huh, how interesting. Actually, I may learn stuff later. But where's parser? We just dive into parser, man. More parser. It seems completely fine. I don't know. If we run into troubles, we can always go back to earlier courses. I'm kind of worried that they... I don't know monad. Like, I know it's an interface, like monad, but I don't know what it does. When to use that, for example. I know traversable... I may know compose, I may not know compose. I think they talk about a new type compose, which is different. Yeah, I've used contravariant for a bit, so that should be fine. I don't know what extent is. AT, kind of no. Okay, we'll be fine, Don't worry about it. Edit the source file exit at the GTI prompt. Issue the command reload. This will compile your solution. Yeah, but like I can't find the module. Spell it then. Can you find course? Or any known package. Maybe we should do a new build instead. I don't... We should Google the error just. Okay, that's probably the answer. We found the answer. We'll try this first. Yes, we have it. Nice. Let's do some coursework then. We're getting a place, man. Not being stuck on project or build tools. Let's see. Where do I have it? It's Twitch, right? Yeah, I jumped into Twitch and then here. The best way. I have a lot of shit in here. Oh, but it's like also to make it work in Vagrant and stuff like that. Yeah. And let's go straight into parser. The recommended order. Parser first. Return a parser that always returns the given parse result. Okay. So I believe the idea is that you can just reload with GTI and then you get any compile errors in there. This is our parser. And I want to keep that open in another window. 23. Oh, look at that. And the parser always returns the given parse result. Parser result A, parser A. p.const. What is a p? Oh, here. Right, so you get a parse result A, and you put it in a parser. You just drop the input. Okay. Yeah, can we get like capture inject? Right, so A to B to A means if you get an input, you just forget about it and return A. So look at this, input to parse result A, we just forget about input because of that. Forget B. First one is parse result. And we receive that parse result in here, which will be the A. And then we get a B, which is inside from the P. Input. And out comes the parse result. So we get a parse result and we just ignore the input. Nice. In a parser that succeeds with a character input or fails with a fails with an error if the input is empty. Good format this. Good. Just fix a lot of stuff. Oh no, it doesn't do comments. How unfortunate. Returns a parser that succeeds with a character of an input or fails with an error if the input is empty. Okay. What is input then? Input is cars. Chars. What is chars? Is this string? Look up chars. What is chars? Doesn't exist. What? Core score, monad, optional. Are we dependent on this stuff? That would be a problem. I didn't do that stuff. It's a person. Do you have a charge for me? What is chars? Oh, course.core. How about that? Is it just a string? Maybe we can just do T. Not a scope. Data constructor chars. You do like info or something? List of char. Weird, man. So this is like a custom string? Why would you do that? Or maybe they made it save or something. It's list. Oh. I'm not sure how good this is. They're defining so much stuff on their own for some reason. Like, you shouldn't do this. You should use the standard library stuff. Alright, so any questions you should just ask if you don't understand what I'm doing with types or something. Yeah, I can explain everything. But let's implement this. It should be... well, it's a bit harder because they made that custom stuff, but we'll figure it out. Shouldn't be too hard, I think. So we just get an input here. And input is... let's see. Input is cars. So this is a list of characters, which is a string. In a parser that succeeds with a character of the input, with a character of the input, or fails, it's an error if the input is empty. Finish pattern match on this, right? We can just do like crappy if. Lambda case. Do we have lambda case? Need a lambda though. Let's add lambda case. So lambda case lambda case allows you to not have to specify the case, like the argument you're matching upon. Like it will be the first argument from a function. Put the music softer. Is it good? Too loud? Looks loud. Okay, awesome. Lambda case. So if you're nil, then we need to give it an error, they say. Turn the parser that succeeds with a character of the input, or fails with the error if the input is empty. What error then? Just undefined? This looks weird. That's from the formatting probably. Maybe we should have done that. Expected end of file input. Maybe it's this error. What errors do you have for me, man? First determine is a parse result error. Okay. And then we'll do like whatever. We'll just put a single one in there, right? Return a parser that succeeds with a character of the input or fails with an error if the input is just a single character. Can't I like recurse into it? Is a parser like monoidal or something? Can I jam them together? That's what I mean. What's the data of parser? So parser. No, you're nothing. You're basically... you have no instances. Oh, they have instances. But they'll come later, right? Testing. Okay, let's look at the result then. Result input. Result input. I do like head, maybe. No, like head. How about that? Reload. Okay, no modules loaded. Reload. Like star. Reload everything, man. No such module course. I just made it. What did they say? That's my problem. Look at that. Attempting to use module main course parser, which is not loaded. So this compiles? Like, I don't trust the GGI thing. Oh, so I'm here. Hi. Hi. Really? It's okay. Doei. Okay. I was interrupted. Let's see. Twitch, right? Let's just do this then. Cable build. Right, any questions you can just ask. Okay. That's why I say, like, it doesn't build. The thing is lying. Data construction, other scope. Parser. Right, it's B. So we need to figure out how this custom cars thing is working. Which is based around the list. You have like head or. How about that? Oh, look at that. We can just use head or. Oh, that's nice. We don't even need to have that lambda thing then. Head or. Still want to have the input though. So I want to wrap stuff around it. I still need to wrap it in the result though. Result. No, it's not like this. Okay. Let's not use head or. I want to have head. Well, let's just go back to pattern matching then. Can't use lambda case either then. So let's make it explicit. Yeah, like this. Dot. Result. What's the result? Where are you, man? Input. Result is input. Right, so usually be X and then usually be D, which is the car. Here. We can ignore the rest of the list. So just take the first element. Return a parser that succeeds with a character of the input. A character of the input. That's 1, right? Well, we can't fit anything else in here. Oh yeah, it has to be 1. Because we got this in the beginning a type, right? Okay. Parser can map. Write a functor instance for the parser. You get a type signature very explicitly. P2P, parser A, parser B. You can just derive it, right? But no, we should what we get is an F, which will map over it, and we get a P parser, right? And what we can do now is basically open up the parser with pattern matching. The answer is always pattern matching, right? Right, so we see the A is in positive position, so that means we're covariant, which means we're a functor. That's some piece of trivia. Not really necessary for doing Haskell. I curse myself with the knowledge of variance. Alright, let's open up the parser then. P fun. And this is map function. This is fun, right? So there's a function inside the parser. Okay, so you may ask, how do you deal with the input, right? Because we can't access this immediately. It's in another level, basically. And there's a couple of ways of dealing with that. We can use fmap into it. This is a thing. And now we have a pass result. And the reason for that is that we can look at the functor instance. Functor Haskell. Oh no, I don't want to have this. This is too much text. We only look at type signatures, right? We're Haskell. And function arrow implements functor. If you can find it. Here. So the first argument of function arrow is, yeah, right, because it's in prefix notation. Which means we can map over the second one. Which is this then. So this will be the parser, or the pass result. And with that, I think we just map F. No. We also need to pass result the functor. Yeah, it is. Well, we're done, right? Is this it? Let's see. Oh, we need to put it in a function again. In another P. Oh, we can reload. No. I don't trust it, man. That's too fast. Too fast. Maybe I lied. Doesn't want me to map inside fun. You don't like to have fun? Fun is applied to too few arguments. You sure about that? Maybe I did lie. Oh, we're learning stuff, right? Then has an input. Fmap into it. Okay, let's start out simply. We're now having A and B mixed up. That's fine. How about this then, man? You like this? Expect no expert. Unexpected lambda. What? Unexpected lambda. Oh, I didn't do the thing. Save or something? Right, we need to fmap into the thing. Because it's an input. Makes no sense. I'm going too far. Give me a second. This stuff is hard, man. And we got an input x. One is also expecting an input x. And we will turn parse result, right? So if we give x to fun, we get out a basically parser A. No, this is the parse result. So now we can fmap into that. And everything will work up in Milhouse, right? This compiles. Nice. It works! Hooray! We've done a Haskell. I know I didn't need to do the previous courses. I can just dive in and everything will work out fine. Just by mucking around a lot. Alright, so this is invariant. Return a parser that always succeeds with a given value and consumes no input. And the reason I'm saying this is invariant is because parsers is well, a functor covariant. And we also have a negative position, so it can never change. Like the A will always be the same type. Ergo invariant. Also some dumb piece of trivia, you probably don't need to do any Haskell, but whatever. I recognize these things now and I'm proud of it, okay? It took like a bit of effort. And yeah. So we get an A. We need to ignore. Oh right, we already did this, right? This was a character. I saw it before. Weird. Constant parser. Look at that. The only thing we need to do is constant parser dot result. What's an input then? Oh, that's cars. We don't even know if it's cars. We don't know if it's A. Right, but cars can be an empty list. That's... Ah, I see. I see. We just do this. Right, an empty. Constant parser. Does constant parser need to be wrapped inside a... No, it's already parser. Cool. So we just used function composition magic to make this work, right? So you have to see it as like a bit of a pipeline. The first argument will be the A thing here, right? That's what we get here. Like yeah, like this, right? And then we get the result out, which you can throw inside the constant pass result, which will return also parser A, and then we're done, right? But we don't like to type, so we do this. Point 3 makes us look like we know stuff. Right, so because we have the custom listing, they didn't write monoid. Let's not do that actually. Why did they do that? Oh, they're exercising here too. I see. But that's why they make their custom list, because they wanted to have you do the exercises, but I didn't do that. Maybe it's gonna bite me. That's fine. Let's see. Infinity. No, we don't want that. I just want to have an empty filter. Pattern. Oh, I have an empty, right? It's just a constructor. Nil. Okay. Now it works. Did it do stuff in here? Oh no, it realized. I don't want to do... Oh. Let's do this. Okay, awesome. Next one. What is... So this is Vera code being maybe we can disable it. What is this set font? Never mind. So this is actually just 3 of these things, but Vera code is being greedy. Return a parser that tries first parser for a successful value. If the first parser succeeds, then use this parser. If the first parser fails, try the second parser. Right, so this is like OR. Parser 1 or parser 2. We need to check if the result is valid. It's error. B. Oh, wait. There's a bit of a problem because we don't have a parse result, we have a parser. So it doesn't fit in here. How do we get a parse result? Well, if we go into the thing, we can get a parse result. So we just add a bunch of lambdas. If the first parser succeeds, then use this parser. If the second parser fails, the first parser fails, to try the second parser. Right, we're just creating a new parser then. I see what's going on. And we get out the input like this. I'm just gonna try parse fun. Parse fun 2. So we're just gonna do this, and now we have a parse result, and we can, because we're inside, right? Like we're inside the parser here. We have an input, and we apply the input to parse fun, which also expects an input, and out we get a parse result. And now we can check if it's an error. And we'll just use the classical if because it's simple. There's also a bool thing, but I don't know. Let's see. res1. Gotta be efficient, man. Oh, it's error, then no, we should do parse fun 2. Else res1. Nice. If it built. Okay, that worked. Right, if you have any questions, please ask me in chat if I'm going too fast or something. I'm being interrupted again, wait. Hey!
Oh.
What up? Oh, ik ben streamen.
Met wie dan? Hey
Internet?
guys, how are you? I'm fine. Heren mensen ook.
Ze zijn vrij stil nu.
Praten ook mensen.
Hello,
Even kijken.
ASMR.
Hey, ja als je...
4 mensen die kijken.
It's ASMR time.
Wat?
Can you hear it? Satisfying.
Ja, doe je wel.
Guys, it's a lovely day in the Netherlands. It is
Mag ik die boomerang hebben?
30 degrees of so. I don't know what I say, but yes.
Je mag die koe hebben.
Mag ik die hebben? Mag ik die?
And today,
Niet die.
yes, is het de livestream of Mila. I'm, hoe zeg je nichtje in het? I'm the niece of Jappie.
Doing fine, man.
Mag ik dat ding op? Hallo?
Wie dit?
Wat geef eens? Mag ik die?
Guys, it's a lovely music. I like it. Yes.
It's
Waar
fine.
praat je dan over tijdens deze
Ik
livestream?
ben Haskell aan het doen, man.
Wat?
Ik ben een course aan het doen in Haskell. Iets om te oefenen met iets. Een cursus.
Alsjeblieft.
Guys, today, tomorrow, I sleep here
Goodbye.
many days in the lovely
Hansen.
Ansen. Guys, bye! Have a nice
Alle
day
4 mensen die kijken.
for people die looking at me. Bye!
Right, let's continue. That was weird, man. Okay, we figured this out. Let's continue. I don't know what the L means. Fix L? Gives the fixity binding and precedence on one or more operators. Integer fixity must be range 0 to 9. Anywhere that's type signature appear. Like a type signature declares the property of the operator. 60, none, left, and right is 50. Okay, let's continue. We need to make a monad. That's the wrong way. Why is it the wrong way?
Oh no!
Parsers can bind. Return a parser that puts its input into the given parser, and if a parser succeeds with a value a, put that value into the given function. Then, if the input is remaining in the resulting parser, then put in parser fails with an error. The return parser fails with that error. And how are you supposed to like to go from these, well, pretty simple ideas and to actually making programs, right? I mean, you know how to solve type errors, but how do you make up these types, right? Something for another day, maybe. Like, I just want to do this once, and I can say I've done it. How many are there? There are quite a few. There are tests. Make sure all tests pass. Get to repeat yourself. Okay. Well, we need to have a f monad. So, what kind of A to parser B? We get a parser A. We need to get out a parser B. Probably gotta create a new one, right? Input. Parser is a monad. I thought the parsers leaked. Like, you need to have arrows. At least in the arrow paper they said that. Was it parsers or was it the other thing? Ah. We get a parser A. We can get input in here. I'm not. So yeah, we get an input. We get a parse result A. But we need to have like an A to get parser B. But
Better.
okay.
Engels of Dutch?
Engels. So what we'll do, let's pattern match on this again, right? Maybe we can get it out another way. Maybe we can get like a maybe, use that. That would be handy. Parse. Oh, this is the thing. Doe jij?
Ogen en blijf achter.
Hou op, joh! Ga weg.
You'll never be back.
I'll be back. So we get an input here, get a parse result out. We can just pattern match on this. Essentially result, right? Result don't care about input, output. and put it in parser B. Or AF. Next F. In any other case, in any other case, we'll just do inside. That's a problem. Can't do that, man. Next F. So we can't do this wrapping thing, I think. Because then this wouldn't work. So we get like two. We get a parser B inside and another parser inside here, right? Well, we get like here. Parser. And it's the thing that monads prevent, the nesting. Because that's basically what you will do with fmap. Like you won't change structure. Whereas monads should like change the overlaying structure. So you can't do this, I think. Can't do this here, because we don't have an input. Yeah, let's just pattern match on this then. P. Parser frame. Right. And from that we can get an input. Let me get the A out then. No, this will not work either. This is pretty hard. I wouldn't expect it to be hard. Maybe it's a good course for me. Maybe I'll learn something. Let's see. Now we're gonna get the input out. Okay. What are you saying, man? If the part is success with value A, put that value at a given function, then put the remaining input in the resulting parser. Return a parser that puts input into the given parser. If a parser fails with an error, or the returned parser fails with that error. Okay, I think I need more coffee though. Like, and have a bit of time to think about this. This is hard. Surprised. I thought it would be easy. Maybe I'm just bad at Haskell. Well, that's also the case. Because like, we get the input now. Huh. Maybe we should also like to structure the B then. Okay, so we get the B out. Yeah, maybe that's the way to do it. Bit weird, but yeah. So we can just do parse then, and we just also destructure the resulting B. Okay. Yeah, that actually Seems the only way to do it. Parser. What's input then? That's x. In x. Variable names, man. Some point you're just gonna give up. Let's see, we get a parse result, so we only care about the result one. We don't care about that input, I think, x. And in case of that, x, we have an a. And we can create a next one. Next f, x. We can match on that again. Maybe with input too. Is it this input then? Like, does the result give Is the same input or just like one step ahead? Just this input. Tell me about your input, man. Input cars. We should know about it because we implemented it, but what's the input supposed to be? With the character of the input or fails with an error if the input is empty. But like, what are the rules about the input thing in the result? Should it like move one ahead? Oh no, they show the example, right? Parse characters ABC, then result is B, C, and A. But I'm doing it wrong here. It should be like this. And this kind of stuff we can't encode in type level. So you just like need to read the descriptions and maybe make tests if you're fancy. But I'm not fancy, so I won't. Also, I'm bad at reading stuff. That's why I like type systems, man. Let's see, what is this? Result nothing. Return a parser, first parser result of value. Well, I used the other thing, right? Like, I have no idea what the other process will do at value level in this case. Because I just like use that error function. So this should be fine. There's no parsing logic going on. I don't know why they put the examples in there then. Maybe to confuse you or something. That's weird. Right, so we need to have this result too then. That will be the next value. Is this why it space leaks? Names, man. Next val. How about that? That's a name. That's a good name. Alright, so we get the next. And we have to do it twice because we need to get rid of the structure. Yeah. There's no other way to do this, I think. Do we care about the result though? No. No. It makes no sense. Right, we need to just do this then. That's the destructuring I was talking about before. Let's see. Parse is yeah. So we need to do it twice because we need to have this initial input to wrap around it. But in this case, if we have any error, we can just do this. Right, so this is like a pattern matching, right? If we have a result, we'll do the next one. If we have something else, we just return that. And this is how monad works. This is all to it. Just this, like, dealing with structure. Well, that was short. Any questions about monads? Anyone? Why is applicative after monad? It should be easier, right? Maybe not. But I'm gonna get a coffee. I'll be back in like 5. No. This one. Coffee break. Yeah, I have it. Okay, gamers, we're back. People watching, nice. Let's see. We need to do applicative now, which is like spell to jam structures together. Applicative. We did fmap. We did this thing, whatever this is. Looks like alternative. But yeah. Applicative first value is pure, which just puts your value into whatever structure you want. And then the second thing you get from applicative is This is also like, it should be, alright, because you implement the monad, you also have to implement applicative. So, you get this parser which has a function inside, and you jam the parser with a value inside into it, and results into will be. It speaks pretty much for itself, but it's how to say, like a bit mind bending at first, because this also, like, function also implements this function arrow. B. Let's see, how do we do this? Need to get a function out first. We need to look at the signature too for parser. Just keep on looking at this, man. Yeah, maybe we need to have a new structure then. Not sure about this. So we get an input again. And I can pattern match on both. So what if I apply x, which is a function, b to x, and then do like this? Does that make sense? I think this is it. I guess based on nothing. So A gives me parse result A to B, right? I need a pattern match again. That'd be annoying. Okay, let's pattern match again. It's the easy way to do this, right? Just always pattern match. You just get the values out. That's fine. A of x. A of x is a function though. The parse result applicative? No. Just a functor. Tricky. Input. I want to say like A of x and B of x. But then we still have the result thing, which doesn't apply. Does it? And they both kind of makes no sense to me. With actual type, parse result A to B. So you're not the function A of X. You're a parse result inside there. That's why I was like at first, maybe I need to fmap into this. But then you get two parse results in each other. That's not good either. We're only gonna give you a parse result if you're actually a result. Then we can do this. How about like, yeah, how about this? Now you're a parse result. And in case of error, you do nothing. But you don't have that. That's annoying. Figured out the right type though. That's nice. Do it by hand. Fine. I already used X. Use Y. The ampersand thing is basically doing this. So no, the ampersand thing was doing this. So you get in a function as argument and then apply it to whatever value. That's the ampersand thing. It's kind of useful at times, just to apply stuff inside context. Could have matched type A with to B. Right. But you don't even carry any typing information, right? Parse next F. Wait, I had type errors there too. Oh, apparently I didn't even finish Monad, right? Well, let's forget about this then. And do Monad first. Yeah. I messed up Monad this time. Okay, let's go back. I'm not good enough for this yet. Clearly. Maybe comment it out or something. Get good first. Apparently, I thought Monad was finished. Maybe I just waved my hand and said it was finished, even though it wasn't. Okay, let's go through them one by one. Parse inks. Probably flip the arguments. No, it's input. Right? But it's saying it's a parser. Does that work? Database type list char with parser A. Oh, I flipped it. Yeah, I did flip it. Nice. That's actually good. That's why I need a coffee, man, to figure this stuff out. Parse next file. Next F. I probably mucked it up again. Yeah, looks like it. Right. And it says this is not a B, but it is. I need to pattern match on all the errors just to convince it. Because it doesn't carry any B-ness around. Or any A-ness around. It's just A-ness. Any... It doesn't carry anything of this A around in this result. What up?
Hey!
Wat is er?
Nee, maar ik heb nog steeds een vraag.
Wat?
Kunnen mensen zien wat je nu doet?
Ja, ze zien het scherm.
En wat is hier zo belangrijk aan?
Niks.
Maar wat is het dan?
Dit is programmeercode.
En dan zo kan je weer iets maken.
Ja. Goed verhaal, lekker kort.
En die 4 mensen die kijken, kijken die nog steeds?
7 mensen nu.
Oké, en dit doe je op YouTube.
Twitch.
Wat is?
Twitch.
Twitch.
Ah.
Oh.
Ja.
Yeah. Zou ik weer even...
Nee. Nee. Weg jij.
Guys.
My niece is interrupting me again. Ga weg joh. Ga weg.
Hoor je mijn stem erin?
Ja, je hoort je stem.
Echt?
Die microfoon is heel gevoelig, ja. Oh, je hebt echt een aangezien.
Zou ik
Ja, nee.
ASMR?
Nee, nee. Nee. Die pony inderdaad, die gek. Okay, well that was fun. Right, so there's no like type information in these errors, but it doesn't know that. So maybe you should convince it by force. This probably doesn't recur either. But yeah, maybe you just need a pattern match by hand. Like reconstruct your everything. So annoying. Whatever, man. Whatever. If you want this, I'll do this. I'll make you happy. Yep. But this is where the film skills come in handy. But yeah, I shouldn't have to do this, I think. Yeah, it likes that. So I just wanted to have like it couldn't, because these types carry around this A. So it couldn't figure out how to make from these things a B. And I need to tell it, yeah, you just can't construct a new one. Well, you basically just pass it around, like it's the same thing. But because of the type information, it couldn't figure that out. Parse result, right? It's the same A. It's parser. What's the input anyway? Oh, that's a list of chars, right? Chars. Just a string though. It's text. Let's see. Okay, let's do applicative then. We need to. We are good now. We can do this. Alright, and if you have any questions, you can just ask in chat. I keep telling people. Maybe we should just put up a sign. Yeah. Same story, I think. Actually, we need to do this again. It's annoying. But it is what it is. Okay, so we have applicative and we have monad. What is this? Return a parser that produces a character but fails if the input is empty. The character does not satisfy the given predicate. Tip. Expected parser will be helpful here. Return a parser that produces a character but fails if the input is empty. Character does not specify a given predicate. Right, so we can just use the thing we made in the beginning. What did we make in the beginning? We made something in the beginning. We made a character in the beginning. Yeah, and they say you can use this. Unexpected car parser. What is unexpected car parser? Char? Oh, it's for the return type, right? What? Naruto, so... Oh, we need to bind it like that. We have monad now, right? So we can just use do syntax. Which is nice. Yeah, let's do that. Yeah. So we get like the pret f. Oh, that's all to it. Okay. Let's start with character. Character, this does a check. Let's just do this then. There it is. If f. So this is do syntax. We're basically using this thing. But because we have the monad instance, we can just use do syntax. Which makes my life easier. Like now it's Python, right? Now we're doing Python in Haskell. So if it's correct, return a parser that produces a character but fails if the input is empty, which is handled by this thing. The character does not satisfy the given predicate. What would I get? Oh, it's unexpected character. What would I get a character then? Maybe I need to make a new parser or something. Is this a character? Oh, that is the character, maybe. Yeah. So we get a character out. We'll see in the type error. If pret f, then here else expected character. JS. It's beautiful. It compiles, so probably works. Well, that was easy. Return a parser that produces the given character but fails if the input is empty, the produced character is not equal to the given character. Okay, let's just do then. Let's just like do that. Does this compile? Oh, you need to have the thing. Oh, they gave us a tip too. How neat. Can we do like something weird? No. How about that? Yeah, that works. Okay, nice. This is point 3 again. The character gets into this, so we end up with a function like this, right? Because this is basically A to bool, right? That's what equality does. And we fill up the one A with char, so the other one becomes also an A. So this char becomes in there. We get partially applied, and then we end up with a function like that. We can just compose, which is nice. I don't know, I always like doing this, it makes me feel happy. It's so neat. But yeah, that's just taste. Tastes differ, right? You may say that you need more names. Alright, so return a parser that produces a character between 0 and 9, but fails if the input is empty. Produced character is not a digit. Let's look at data.char. Char? Alpha. Is upper, is lower, is space, is control. Is digit. How about that? Okay. Yeah, this is it, right? This already satisfies to this char to bool thing. So you don't need to get any arguments anymore either. Oh, it doesn't know about this digit. Bool with char bool. Oh, I don't need to compose, right? Just do this. Ah, okay, so the difference is this will first eat an argument, like I just said, right? The x. It will do this. But if you compose, yeah, that's what you do with compose. In this case, we don't need to do this because we don't even get any arguments. So is digit is just an argument to satisfy of type char to bool, which fits in here, char to bool. It's the predicate. Good, we got a code reuse. Return a parser that produces a space but fails if the input is empty and the produced character is not a space. Okay. There's an space too. Let's use that then. This is what I meant, like we should use standard library stuff. It's nice. Probably shouldn't write your own parsers either. You should just use like, try to use parsec or stuff built on top of parsec. But yeah, I suppose it's good to understand this stuff on level. It makes you working with types easier. Right, what is this? Return a parser that continues producing a list of values from the given parser. Use list 1. Here, what is list 1? Did I implement that? List 1 test. What is list 1? Oh, there it is. We didn't do that. Oh, this is it. Wait, what? Use list 1. But we haven't even implemented list 1. How can we use it then? What's the difference? Return a parser that produces at least one value from the given parser, and continues producing a list of values from the parser. Ultimately produce an unempty list. List. Can they like use each other, right? That's not possible. Right, I think they made their own list. Mostly because of the exercise. Maybe not. This is not a normal list, this is a normal list. But there's some type weirdness going on with that. In the parser, they're producing a list of values from the given parser. It's just a reverse then. No. What? Parse list character. I'm not sure what this does. List digit 1, 2, 3 ABC. Result ABC 1, 2, 3. But it's just arity maybe, like all the other stuff has been just one thing until now. And we can use this list thing to make it more, like parse more things at once. So we need to keep on going. Use list 1, but we can't use list 1. It's not implemented. In a parser that produces a list of one value from the given list. And continue producing a list of values from the given parser. What's a list then? This thing. I like how they set up import test.quick check. Just start out like learning Haskell with quick check. It'll be easy. Or maybe for them. Well, need to continue consuming input. This is like self-recursive maybe then or something. I need to look at the type of parser again. Alright, so we keep on going as long as we get results. We just jam the results in a list. Is that it? Yeah, we wrapped a list around the parse result, right? Okay. This is the input. We can apply input to that. We're gonna... How are we gonna do this? Maybe like... They say we should use bind though. And this thing. Oh no, they're not saying that we should use bind at all. I invented that. What does that thing do? Return parser that tries to the first parser for a successful value. First parser succeeds, then use this parser. First parser fails, try the second parser. I don't need to have 2 parsers, man. I want to make a list. I want to have a list. Let's make an input. Parser this. That's a problem. You're gonna be a list parsers all day, man. No. Well, maybe you are. No. Well, yeah, you are. No. What am I doing? What to do? X to input. And if you get like a result, let's just start doing something and see what we end up with. Well, at least we can put it in a value, right? We know how lists work. Is the list applicative in your case? It would be nice. Maybe I should have... No. There's no type classes. Oh my god. It is applicative, but only pure. Well, use pure at least. That's nice. So I haven't done the list exercises, so I need to make sure that actually stuff is being implemented there or using it. Alright. Can I just fmap pure into this? And it will be done, right? Or is this thing actually supposed to do more? At least this will compile, right? And compiles fine, right? We're done. But that's not what they want. Return a parser that continues producing a list of values for the given parser. As long as you can, you just should keep eating. So we need to have like a little where binding, I think. Because we need to do some kind of recursion. This is obviously not what I want, right? It compiles, but I'm just saying that whatever value is inside S should now be a list through the magic of pure, which is here. No, this doesn't seem right. Well, use pure. Okay, I did it. How do you keep pulling out values then? In recursion, right. That's it. We'll have some input, which is a list of characters, and we can keep parsing these characters. Right. So we actually need to have a new parser then. Which is gonna eat this as long as we can. Are we gonna parse it though? Oh, it'll give us a result. Yeah, but we have to do this. We need to eat. The result is not the monad, unfortunately. But yeah, so we'll get a function like where eat is input. Well, can't we traverse? How much stuff is in the list? It's reversible. No, he doesn't know about that. We have fold. Let's do it by hand then. You're eating. Tell me about yourself, parser. You're an input and you're a parse result A. But this doesn't suffice. You need to be a list. Parse result A. But then I can do recursion. So yeah, I need to have some kind of folding structure to collect you. And I know for a fact you'll be A. List A. How about that? That's the classical pattern of doing collection. Just keeping track of it. Imp. Pref. Yeah, how about that? Let's start with nil. Okay, now we need to parse the imp. With parser S. Yeah. Let's see. Now we need to do some pattern matching. And we'll step over it like that. Eat D. And what list will you eat? Pref plus A. How about that? And in case of error, we quit. Even though this doesn't work, unfortunately. Let's see. List car with parse result list A. Could it match type list car? How did you even get to car? Char? Parse result list A. Expected type. Input to parse result list A. Actual type. List char, list char. Did I flip it again? Keep flipping it. And because of the polymorphism, the type errors tend to get mucked up. Just something to be aware of. Expected type input parse result list A. Actual type list char. Which is input to list char. I see your point, man. Does list even have plus plus? This listing? Oh. How do you append? This is useful. Maybe you should implement this. Kind of annoying they didn't do it. Let's use cons. Let's just assume it exists. This is annoying. I have to do these previous courses before I can do this one. Not made for streamers, man. Eat nil. Why won't you eat nothing? Input pass result list. List car. I fixed that. Parse input parser. That's this one, right? Could make parser A with list char. Or how did he even like come up with that? Pass result list A. Input to pass result list A. Actual type list char. I never say it's list char. I say it's A. Need scope type variables. The only way. Did I make it up here? Why did you even add the parentheses? Right, keep flipping these. Parse. Oh, I can use cons. Nice. That's just one. I never know how this works. Pretty much type A with parse result. Not the parse result though. This. A. Yeah, because we keep eating it. In the other case, we just stop. Wouldn't match type A1 with A. God. We need to have scope type variables. Can I enable that? Is this allowed? Yeah. Maybe you should just like make a separate function then. It's the same thing. See the problem with this too. Let's do it like that. Nice. I think we figured everything out now. Or not. Right, you need to keep on giving the parser to yourself before you can eat again. Come on. Eat your breakfast. Right, and we're gonna put out the parse result. Yeah, that makes sense. But then, yeah, but you accumulate by just keeping eating results. So we get an input, parse the input, match on it, and we eat the next one. But at some point we're gonna fail. So we just do this. Yeah, this makes sense. And then if we fail, we'll just fail. That's fine. We don't get a result, but we get a failure, we just return the failure. And then everything is coming up Milhouse. Right, and it needs to make sure it's a list, so we just fmap cure into that other case. That's fine. I think this works. Okay, cool. We have a list. Recursion. Actually, this is how you do GADTs too. You collect like this. You put it in the argument. And you just keep on adding it. Parser imp. But yeah, we just keep on adding the result from the previous. And just keep on going down deeper. And build a result type. We didn't do the OR thing though. I wonder what that's about. So are there tests? Where do the tests? The quick check stuff? Yeah, I'm not sure if this is right though. Let's do this. Or this. That'd be pure though. Let's see. This character. Return a parser at least one value from the given parser. Wait, let's look at the repo. Yeah, this thing. How do you use this stuff, man? Yeah, just like install the Glasgow Hub compiler. It's so easy. Just use your package manager and everything will be alright, except never. PCI step completion. Thanks for telling me the obvious. I didn't know that actually, but. Some questions take particular form. These are called what the fuck questions. What the fuck questions are those in the form of similar? What does underlying bar mean? Well, answerable with the info command. Info. Oh, didn't know that. Follow the types. You might face up. Yeah, but it doesn't always work, right? Because in this case, I showed it in the beginning, you can just fix this function by doing pure. F-mapping pure into this thing. But it's not like the behavior, the expected behavior is this function. Like, types help you a long way, but not really always the entire way. And even though I'm not sure, even now I'm not sure that this is right. Looks right. Maybe. I would like, I think they have tests for this somewhere, but I don't know how to use that. Let's see. Ooh. Oh, look at that! Parser tests. Hopefully not quick check. Ah. This test. Mini 3. Not quick check? Okay, let's try running that then. Wait, I did some set spell too before. Maybe also test them. If you can find it. Did it like running the test? Oh, here it's here. Tests are able to run either with built-in test runner, but have no requirement beyond this. Tasty. What is tasty? Before running tests, ensure you have an up-to-date installation of cheats. Don't do this, man. Yeah, it doesn't work with nicks or reproducible builds. The Haskell tooling, it's a bit painful. Maybe used to run test. To run test, load the relevant module and then run course test. Each test module exports a function called course test that may be used to run test. And then run. Ah, it's just for the one thing, right? Let's do that. Import parser. Import course Sampler test. Let's find module course parser test. Yeah, that's a problem. Misspell? No. You can ask Kabel to test you. Maybe quicker. Everything's broken. Well, it compiles the test at least. That's good. And what's the difference between new and old Kabel? I don't know. But there's a difference. Alright, so everything's broken. That's fine. I just want to have the parser though. Module, more parser. No, we're not doing more parser. List test. Applicative instance is failing. Ah. Find value parser is also failing. So we're having more mistakes actually. Even alternative parser is failing. Even value is failing. Right, maybe we should fix this first then. It could actually be the case that this other stuff is failing because the value parser is failing. Can I run this for one module? Kabel new test. Course. The test command can only be run test suites as a whole, not for files modules within them. Oh. That's annoying. How's the value parser wrong? You don't like my composition, man. Okay, let's see if I can just make it work with grep. And then we do like lines below or something. After context, do like 20. Doesn't work. Look at that. We made it run only for this one module. How nice. Aren't we clever? Succeeds with the value. APC B. We got value result. Nothing. Return a parser. Return a parser that always succeeds with a given value and consumes no input. But we're not doing that. Constant parser. Oh, you're dropping it. Dare you? Oh, now I see. You should do this. Just like this? Input is chars. Result input. Maybe it is. See if that builds. How about that we use lambdas? Okay, so now all this stuff is working. Eh? Why are you showing me up to now, man? That's weird. My grep broken. Append character, star. Ooh. How about that, man? Applicative is also broken. Just fix that. What? Expected XIZ AP. XYZ. But you need to have P in the. Why are you testing pure, man? Weird. Okay, we have A, which is the function one. We destructure that and apply the X input on that. And then we pattern match on B. And if you're successful with P, we can apply function inside. Oh, they tell us to use a monad thing? That's really weird though. Because this is a superclass. Monad. Well, not an... Do they have their own type class thing? Is that legit? I can use the monad thing. But, of course monad. Really? Do syntax then does do syntax then work with that? Monad. Yeah, you have it. You're redefining it. But it's still a superclass, so it's like kind of strange, right? How did you even do that? Does it work with do rebindable syntax? That's the thing. Yeah. Why did you re-implement monad? Oh, this actually sounds like fun. We should do this one too. One time. Some monad stuff. Or function error. Nicholasly category. Oh, that's this one, the fish, right? Clasley composition. It's the wrong way though. I'm getting... Why is the wrong way? Rebindable syntax, what does that do? Enable rebinding of variety of usable built-in operations. Suppose you are importing the prelude of your own in order to define your own numeric class hierarchy. Completely defeats that purpose if literal 1 means prelude from integer 1, which what the Haskell report specifies. One piece of built-in syntax refer to whatever is in scope, not the prelude versions. What about monad then? How do you write that thing? Ah, this one, yeah. Do notation is translated using whatever functions still are in scope, not the prelude versions. So this is what they did. They just made their own type classes and then implemented their own this thing. But it's not gonna work because currently this thing is not implemented. That's trivial actually. Just flip this one. Monad F. Yeah, flip. How do you write that thing? Done. Right? Optional. Oh, that's optional. What? Optional. Exactly one. I can just flip this thing, and that's the other thing then. And we made do syntax work. Is it? Yeah, it's using that one. Spaceship. However, use only join and fmap. Well, that's also trivial, right? It's one fun. One. It's just how it works, okay? Just right, now we made do syntax work, which is important to me. And apparently we can use yeah, we can use this operator. It's so weird that they flipped it. Yeah, we can just use do syntax then. Just delete everything here. And we'll just work. Do. If bv. How about that? We made proper names. Then bv. Whatever, man. Is this even a thing? Like, does this compile? Yeah. You can install the Loom line too. Fail? What are you talking about, man? Oh no! Let's implement join. Okay, we'll implement join too. Let's see. You have a monad f. What would we do? Or what would we do actually? Okay, well, apparently also doing the monad course. Oh no! Even this one. We have to re-implement that thing? Okay, what? Whatever. No, we don't have to do it for exactly one. We don't care about that. This is just a type class, right? We don't need to implement that. It's fine. We just assume it exists. It's only a type. So this is the contract we made. And we don't need to do any of that. We just know that this f has that operation available. If I remember how to do it. That thing is available. F-A. It's actually only one thing you can do, really. How about it? You just do it like this. Is that a join? Would you compile with that? Apparently. Okay, so this is how you do join in real life. Wait. Let's stare at those types a bit better. I can explain that. That's the only thing you can do, really. Okay, so the argument I put in was it, right? So this thing becomes A to A. And we put in FA. So we just said like, pull it out. I don't know, it just works, man. This is what happens. You have these nested monads, and if you do this thing with it, then it becomes unnested. That's it. There's reasons. I don't know what else to say about it, really. Oh, and applicative is also working now. So we made applicative work by just using the monad stuff. Sequence parser test. Oh, there's a lot of stuff in here. Oh, wait. I need to have more lines. Tell me about A. After context. List test. So digit test is working, space test is working, list test is failing. Unexpected end of stream. List test is failing. Oh, let's see. Actually, I have to eat now, so yeah, I'm not sure if I'm gonna continue with this because kind of wanna work on Raster 2. Maybe I'll do the X-Monad stuff though. Or maybe Cave Squid, I don't know. Anyway, I'll be back at like 7 or 8. Yeah. But I'll commit this and I'll upstream it. Right. Mega doesn't like that. I don't know, the server-side rendering is more interesting for me. And although like this is all interesting and stuff, I'm not sure how to apply it to anything. Maybe you should like instead make a game reflex. Would be more fun to do. But it could also be like once a week. I don't know. Because like I'm working on this and I'm thinking like, okay, what am I really achieving by doing this? Yeah. Doesn't really combine well. But that's fine. Anyway, see you guys later.